is that later on, right now, the good news is that some of the teachers have included Git in as the requirement in their subjects. I'm going to show which subjects they are. And without further ado, let's start. So about me, I work at Ericsson. Um, I'm learning to play the flute now, and I love sports of all kinds, and I love to cook, especially very spicy food. And you can find me at linkedin.com/in-pesulosan-elte if you want to contact me after the talk. So let's start and see what the problem is that Git is solving. So we need to understand what the basic problem is, and then we can understand what the solution is and how great this solution is. For example, let's say you're working on a project, and you have a bright idea, and then you have another idea, and you say, okay, how about this? I make 2 copies of the project. At this time, I work on this idea in this file and the other idea on that file. And you, in the end, you end up with lots of files which have names which don't convey a lot of meaning to us. And in these files, it's very tough to go back and forth. For example, let's say if I have Notepad open and I want to go back, if I close the Notepad, I won't be able to go back. If I save it, it's in its final state. So very limited saving capability, limited capability of going back or going forward. And as you can see, really doesn't work for more than one person. I mean, if I send this to my colleague, the first question is he's going to ask me is which file should I take a look at, because this file has the name final in it, this has final in it, and this has the name latest in it. So he's going to be confused, and he's going to say, can you please tell me which file it is, the one that you last worked on? This is not working, and this is completely disorganized. Let's dive a bit deeper into the problem, and let's sort of specify more aspects of this problem and what questions can arise when you're working with more people or you come back to the project after a while. So here are some questions that can arise. We want to know what was changed. That's kind of easy. You can open 2 files and you can compare both of them. But is it the best way to compare 2 files visually? I don't think so. That's pretty slow. The second question is, why was a certain change made? Now, this is an important question because when you're working on the problem, you remember all the specific details about it. But let's say you come back to it after a month, after 2 months. You're going to forget pretty quickly why a certain change was made, and then you would have to go through it again and see, oh, you know what, this is why I made the change. This is really important, especially when you go start developing code. Sooner or later, nobody can remember everything, and it takes only 1 week to forget why a certain decision or why a certain change was made. And this information is really important. And also, let's say you are handing over a project or someone else is trying to help you, they will have this question the most. They will say, okay, why was a certain solution chosen over solution B? We need to tell them that, okay, why did we choose to make the change we chose to make? A small problem, I think that happens. We make the changes, but every time we have to make a copy of the project. So it's messy, it's difficult to collaborate with others, and it's painfully slow. I mean, I don't have the time to zip all of this, send it to someone, and then wait for someone to work on it, zip it, and send it back to me. That's just not going to work on an individual level, but also let's understand it from the perspective of a business. Nobody is going to be that inefficient in the business world. So this is where Git comes in. Now, let's not be scared by version control. It seems like a big word, version control. It just simply means It's a tool to track changes in the files that you're working on. It was developed 16 years ago by Linus, and Linus is the person who has worked the most on the Linux kernel. You can say he's the father of Linux kernel as we know it today. And so he developed it because so many people want to work on the Linux kernel. It's an open source project. It's a big, huge project. And today, 15,000 people have contributed to the Linux kernel repository on GitHub. And so what I can say is that we have a question from Anis.
I can see the screen, so if there are people who can't see the screen, please react to Anis's message.
Well, the session has started, so okay, it seems like it's a problem on Anis's end. So let's go ahead. Why am I telling you this is developed by Linus, and why does it matter? It matters because it has been battle tested. We want to use a tool which has been battle tested. The bugs have been ironed out, and it has been tested on a huge project. It's the Linux kernel. If it works for that, I think it can work for any project. So it's a fantastic tool. It's secondly free and open source. You don't have to pay a dime to use it. Over the years, a lot of people have worked on Git to make it lightning fast. It's also works as a distributed version control system. What it means is that every person who's working on a project has a copy of the project on their drive. And then what they can do is they can just use that copy and send it directly to someone else. And they don't have to wait for a central server. I'll explain this further in detail later on. And Git does not only work for code, it works for anything that is text-based. So let me give you an example. Let's say you are writing your resume. Over the years, your skills will improve. You will learn different skills. You will move around. You will change a lot of information. So you can use Git for that to version control, keep track of your resume. Let's say, let's give a completely different example. Let's say I like cooking and I have a recipe book. And in that recipe, I have one recipe that I just created right now. And I went ahead and I tried it out, and then I want to do some modifications in it. Git is also pretty great for tracking the changes which I will make in the recipe. And the final most important thing is that Git is a separate entity on its own. If there was no Git, there wouldn't be no GitHub. So all these platforms such as GitHub, GitLab, Bitbucket, they exist on top of Git. And you can use Git without ever using GitHub. But GitHub exists because Git was there first. So these technologies are built on top of them. Please don't confuse Git with GitHub. As you know, some people confuse Wi-Fi with internet. It's completely two different things. So Git is a separate entity on its own. So I want to answer one question here that arises whenever learning a new technology is when and where I will use this. If you are a student of ELTE, most likely you will have seen in the first semester when you use the functional programming, some of the questions and the solutions, and a lot of material is available on GitHub on its repository. The second time that you will get to use Git by yourself, and you will be required to use Git, is in the two subjects, tools of software projects and software technology. I think it's in the fourth and fifth semester. So you will have to use Git quite a lot in the fourth and fifth semester in these two subjects, and without that you cannot pass. And after your first year, you will start looking for an internship. You can start looking for an internship right now also, but in the business side of things, Git is used everywhere. and it's going to be pretty difficult for you if you don't know how to use Git and you get an internship. Obviously, the team will help you out, but you will be required to learn Git at one point or another. And once you understand the basic concepts of Git, you will quickly realize that you might want to version control a lot of things. It might feel like a hassle at first, but the benefits really outweigh the disadvantages, if there are any. So let's go ahead and introduce GitHub. It's a code hosting platform first, and then secondly, it's a social network and has some project management tools built in. It can help you create issues. It can assign issues to people. It can say how long the issue will take. It gives us pretty nice graphs and a lot of statistics, which aren't necessarily important right now. If I can give another example about the relation between Git and GitHub is that let's say you made a website and you have it on your computer, you want to show it to someone else, you will have to upload it to a web hosting platform. Git and GitHub have sort of a similar relationship that if you have a Git repository or a coding project on your own computer and you want to collaborate with other people easily, or you want to show it to the world, you can just upload it to GitHub and show it to the world, and anyone else can come in and also contribute to it. Anyone can come and take a look at your profile, and you can list out your skills there. It's sort of a second resume. So it's pretty helpful, and you can also find people who have the same interest in you in technology, who are working on interesting projects, and you can follow that as well through GitHub.
Faisal, may I ask you one question?
Yeah, sure.
Like if in the GitHub, like if I have uploaded some of my projects, so can anyone else can contribute to it?
Yeah, if if you have it set as public, anyone can go to your profile and anyone can contribute to it. They will download it to their computer, they'll make the changes and then upload it back again and create a pull request, and they will be able to contribute to it.
Okay. Okay. So it will be also uploaded on my profile, right?
You can approve the change. So it's up to you if you want to accept the change or not.
Okay. Thank you.
All right. So this is a pretty important screen. I'm going to be coming back to it more times, but I just wanted to have kind of a translation between actions that we do generally without Git and what those actions translate into within Git itself. So let's say, for example, you're working on a project with your friend and your friend uploads it to Google Drive. When you download it from Google Drive, it's the same as doing a Git clone. Whenever there is an update to the project, you do a Git fetch. Let's say you have a new idea, you want to start fresh, you create a Git branch. When you want to save whatever work you have done on, do a Git commit. When you want to show what you have worked on and saved to someone else, you do a Git push. When you want to compare, you do a Git Diff. Going back and forwards, you can use Git checkout. And the repository is essentially a folder, a project folder. And right now you might not understand all of these commands, but we'll come back to this slide later on, and we'll get a better understanding of it. And there is a question that pops up quite frequently, is that should we learn the command line Git commands, or should we just download the graphical interface of Git, let's say GitHub Desktop, and start using that? There is nothing wrong with GitHub Desktop. The biggest disadvantage is that sooner or later you will go searching on Google and you will find a solution on Stack Overflow or somewhere else, and it will be in the form of command line. So it's just better to learn the command line because then you'll be able to use any of the graphical interfaces available, but also you will be able to take advantage of the solutions on Stack Overflow. If you don't understand the command line, it's going to be pretty difficult. And so in the end, you will have to essentially learn the command line again. In my opinion, people end up using both, but the knowledge of command line, Git commands is pretty important. And they are not really complicated at all. They're very easy. Okay, so I wanted to give explain the Git commands through a pretty easy example. I didn't want anyone to get confused by any code or anything. And so let's think of a situation in which I'm a writer. I'm working in a large firm which writes stories, writes books. And our latest project is that we have to write children's story series. It will have a cat and a mouse as their characters, and we will write the stories about their adventures together. And in the process of this, we are going to use Git and GitHub both. Later on, there will be collaboration between multiple writers, but in the beginning, we'll be working on our own. And the aim is to understand Git concepts through an easy example. So Git can be installed locally on your computer by going to gitscm.com and installing it with the default settings. You don't need to change anything. The installer is pretty intelligent. It automatically installs everything on its own. And now I want to take a moment and ask everyone the question that, do they have Git installed on their computers? Please write in the chat your answers. All right, great. It seems like a majority of you have, yeah, you can use Homebrew. It's not a problem. Okay, yeah, so seems like most of you have Git installed. The first thing that you are going to do after installing Git is tell Git who you are. Just like when you install an operating system or set up a profile, you have to tell them who you are. We have to tell Git who we are. Right now, I take the identity of William Hanna, and I tell Git also that, okay, this is my contact address. Without these commands, Git is not going to work. It's going to throw an error. So the first step is to tell Git who you are. It's the same as when you create a Word document. The Word document automatically takes your name and adds it in as the author or the last modified. So I want to know who is following along with me.
Also, I wanted to add that I think people can unmute now. I should like they can unmute and ask questions if they want to or add something, so they don't have to type in the chat necessarily.
All right, great. Okay, then let's move forward. If you're still here and you want to know the command, just it will be here. It's in the slides also, but you can just use easily Google and you can search how to set up the email and the name in Git on Google. The first result will tell you these commands. Okay, so let's go ahead. We need a place to start working. That place is going to be, okay, how do you check if you have configured it correctly? Good question. Let's see. So if you open up terminal and you type git, it's going to show you its page about all its commands available. And if you see this, it means that, yeah, you have set it up correctly. That's the easiest way. Okay, all right, let's go ahead. So I want those who are following to go to github.com/new. They'll be presented with this screen where they can create a new repository. You can name it whatever you like. You can choose to make it public or private. For now, it really doesn't matter. But the important thing is this box, add a README file. I want everyone who's following to check it. It's just going to make it far easier for us to start on the project and not have to get in a few extra commands. If you don't use this, you will have to add a few extra commands that I just don't want to get into right now because it's a beginner's tutorial. GitHub is going to tell us that, okay, the default branch is going to be main, and we are going to press on create repository, and we will have our repository. Okay, as soon as it's created, we will see this page. I think I'll open the repository in my browser and come back here. So yeah, this is what we are going to see, the information before, what branch we are in, the number of branches, tags, you don't need to worry about that. The important information is this identifier here and the number of commits. So as you can see, when you make it for the first time, you're going to just have one commit and an identifier that's going to be different. And then you're going to have the rendering of the README file. So whatever you type in the README file will get rendered here, and you can add a bit of styling to it. And it's like you can think of the README file as the introduction to a project. And it can contain information which is helpful for a person who's new to the project, how to get started on contributing to the project or what the project is about. And I think you have seen this, I guess, somewhere. Yeah, okay. So now let's go ahead and start writing our story. So to start writing our story, right now the repository is only on GitHub. And we need to, just like as we download the project.zip file from Google Drive, we are going to do a Git clone. So if you press on the green code button, which was in the dashboard, you'll get a link. And you just copy that link, go into your terminal, and you type in Git clone and that link. For the first time, Git might ask you for your credentials, but after that, it won't ask for credentials anymore. It's just going to save it. And it should look a bit like this. when you run the command, it's going to say done, and it's going to tell you a lot of statistics about how fast Git did this command, but you don't need to care about this. You just care about if it says done. All right, let's go ahead and let's write our first story. This is my story. I'm going to give you guys some time to read it. You can write your own story. It's not really important to know the whole story, but it will come up again and again. And let's wait for those who are still following and a bit behind in the process. If you are done and ready, just let me know in the chat and I'll continue. Okay, I'm gonna wait for 1 more minute. Okay, so let's say I wrote this story. I saved it in a text file in my project folder, inside the folder that I just cloned. Um, and I saved it. And what should I do next? And for those who are following, you can just type whatever text you want and save it, and you can follow the next command. Okay, so I want to ask Git, hey Git, how are you doing? How is my project doing? I want some information from Git, what it thinks about the work I have done in my project. And so the command for that is git status. Git is going to tell us a bit of information, which we already kind of saw on GitHub. It says that the branch right now is main, and right now its status is that it's up to date with what was on GitHub. And next is saying that there are some untracked files in the repository, and it's the file that we just added right now. And so Git by default does not want to track every file that we put in the project folder. Why? Okay, so I saved the slide for this. I skipped over it, but let's go back. So you need to go inside the folder that you just cloned. So if you named your repository stories, you need to do a cd stories. You need to go inside. What you're most probably doing is you're outside and you do a git status, and it's going to give this error. So what just happened is that whenever you use any git command, Git is going to search for this folder .git, and if it does not find this folder, it's going to give this error. And please don't mess around with this folder. It's not supposed to be seen. It's supposed to be a hidden folder, and if you just leave it, life will be great.
Okay, so what should we do now to?
So I need you to go inside the folder that you just cloned.
Okay.
And if you run git status inside of that folder, so right now, as you can see, it says desktop here. And then I got into my folder stories, and then I ran a git status after I had done my work, and it successfully says, yeah, I found some work that you had done, and I'm not tracking it. Does anyone else have this issue that Mehdi had? Well, I guess the silence in the chat says no. All right, great. Okay, so I was explaining why Git doesn't track everything automatically. It's because when you're developing and you start building some project, this build process is going to create a lot of temporary files and artifacts, which we don't want. We don't want Git to track automatically. So we only want Git to track important stuff, and the best way for that to happen is Git just says, you know what, if something is important, you tell it to me manually, and I'll start tracking it. And so to tell Git that it should start tracking this file, I can use the command git add with a dot inside of it. And also you can, this command is the command, it says that whatever is in this list of untracked files, track all of them. If you want to track just a single file, you can just put in the name of that single file and Git is going to start tracking it. Right now, as you can see, the name is red. It means that, well, it's not ready for commit. It's not being tracked right now. So any commands that we use moving forward, they won't include this file. So let's do a git add dot, and when we did that, we do a git status again, and now the color is green, and it says that, yeah, well, you know, your changes are ready to be committed. And right now we see this word staged. So let me explain the concept of staging. When your file is untracked, it has the untracked. Git says that it is untracked. Even if the file is being tracked, you need to put that file into staging for it to be included into a commit and to be pushed. So if you don't add the file to staging, it will not be included in the commit, even though you have made changes to it, and even if Git is tracking it. Yeah, you need to tell explicitly which file needs to be added into commits, because maybe you have done some work and you would like to split up the commits and say, okay, this commit will only include 2 files, the rest of the commits will include 6 files, and that's why this is extremely helpful. So now we are at the most important command, I think, the Git Commit Command. It has a very easy, it's very easy to use. You just do a git commit -m and you include the message. Now I want to talk about good commit messages, what commit messages achieve, and why they're important. It's important that when you're writing your Git message, you understand that this message is going to be read by someone else who hasn't done this work. And so you need to give them concise information about what was done, but also why that was done. So as you right now see that I wrote a little Christmas story. It's because as an author, it's December. I want to write a story about Christmas, and well, it's Christmas, so I have to involve a lot of toys and gifts. So whoever is going to read this commit, if it's someone else, they are going to understand the reason behind the author writing the first story as a Christmas story, because they know that the author wrote it in December, and That's one. Let's see what Git tells us about our commit. It's going to generate an identifier for our commit, and it's going to tell us on which branch it has committed. It's going to tell us about what the changes are, a summary of them. That's not important really. Unless there's an error here, you really don't need to care about the output. And so I wanted to take a little break right now here and ask everyone about their status, if they are following me, how far they are, if they have any problems until this step. All right, good. So let's go ahead and so right now we have a git commit, and it's right now on our computer only. So if I want to show my work to someone else, I will have to push it, upload it to GitHub. How we do that is using the, oh yeah, I hit this picture. So bad commit messages, this is how someone else is going to be looking at your code if you write bad Git messages. They are not going to be able to understand what was done. So Git push, it's gonna show management what I just did, what story I just wrote. Very simple, Git push, that's it. It's gonna tell you, yeah, I pushed it to this link, pushed it from the initial commit ID, and right now the latest commit ID is this one, and it was done on these two branches. That's pretty easy. Just gonna wait a little bit for you guys to initiate a Git push, and then I'm gonna start. All right, so as soon as you do a Git push, you're going to see the commit message on GitHub right here in the on the dashboard, and you're going to see the file that we just uploaded. I hope everyone's push was great.
There's a question for you in the chat.
Yeah. Yes, modification, staging, and committing. Yes. So why is I'll go over this again. Why staging is important? Staging is important, let's say, because you have done several different types of work, and you want to make different commits for it. Where we don't want to, we want to have commits which have very specific purpose. And you do staging because, let's say, locally you have done a lot of changes, but you only want to include the changes in a few specific files. So you will get those files, you'll tell Git, please put them in staging, and then you'll make a Git commit, and only those files which are in staging will get committed. I hope that answers it. All right, great. Okay, so now let's see what's visible on GitHub. Let's say I'm management, I go on the repository and I see this. Okay, great. My writer has done some work. Let's go ahead and read it. I open this up. I'm reading it. It seems like a nice story. Great. Oh, I see there's a spelling mistake. All right. And I also see that, I don't like this. I don't like this file name. And I want to be able to tell my writer or developer, please make a few modifications. And so what I can just do is, if I want to point out a specific line, it's really easy. I just go to the line number, I press this line, it highlights this line. I go over these three dots and I say reference in new issue. And if I say that, it's going to take me to this window where I can, it's kind of like a post on GitHub itself. It's going to create an issue. It's going to allow us to write a detailed description of what the problem is, give it a title, and then we can preview it before submitting the new issue. So let's go ahead and create an issue in our slides. This is what I just showed to you. Okay, I think I can go ahead. All right. So management decides number one, the spelling mistake has to be fixed. The file name contains the extension twice. And also management took a decision that, well, we don't like the name Jinx so much. We are going to name the mouse Jerry. And so these are the three requests from management. And so once you submit it, this is kind of how it's going to look like. And it's going to allow us to easily, for the developer or anyone else who opens this issue, they can easily see that the spelling mistake is right here. So it points out a specific line, and in the same way, you can tag a specific developer, a line, a commit, and attach files, paste screenshots, and you can say thumbs up or give a bunch of emojis to it also. And now, so I have my work for the next day. I'm going to work on this issue as a writer or developer. And I say that, you know what, I opened up Notepad, I made the changes, and now I want to visualize those changes, what they are. So let's say I made those changes. I don't want to bore you making those changes. I save the file, and I want to see the difference that there is. So what I'm going to do is issue the command git diff, and the diff command is going to take what is on GitHub right now, and it's going to compare it to what I have locally, and it highlights the previous version of the line in red and the current version of the line in green. So here you can see that I renamed the mouse from Jinx to Jerry. It's the same in these lines as well, and I removed a bunch of extra spaces that were here. But you'll note that Git tells us that the file name is still the same. So does this mean that I haven't done one task? I've done the two other tasks, but I haven't renamed the file? Well, let's see what happens. So here's the essential Git workflow. You do a Git Add, you do a Git Commit, and you do a Git Push. And so what I'll just do is I can do Git Add dot or the name of the file. I'll write a commit message, and here's what's important. I say I did two things. I fixed the spelling and the name, but I couldn't rename the file because of an operating system issue. And then I'm going to do a Git push. All right. And once we have done a Git push, what we can do is we can go to GitHub. We can press on the on the commit identifier or the commit hash, and we can go to the latest commit, or we can, if you have done more than one commit, you can go into the list of commits and press on that commit, and it's going to show you the diff for that commit, that specific commit. So GitHub Diff is much better, I would say, because not only it highlights the line itself, but it highlights what was actually changed in the line. And what I want to say right now here is that you shouldn't really rely on GitHub Diff, because then this means that you have uploaded your work and everyone else can see it also. It's better to go back to Git Diff when you haven't pushed your work and just confirm, okay, these are the changes that I wanted to make. And I'm happy with these changes. And then I'm going to commit, and then I'm going to push, and then it's going to be visible to everyone else. Okay, so now 2 tasks are done and 1 single task is remaining. So let's go back into the issue and let's tell management that, hey, you know, I couldn't fix this issue. Maybe you can ask someone else, but I did fix two of the requests. And so we will just tag another developer. We'll say, oh yeah, writer 2 will fix the issue, and writer 2 says, well, I'm on it. So again, from the perspective of writer 2, we'll do a git clone. We'll move into the directory, and we'll change the rename the file, not change, sorry. And how you rename is as you use the command mv. That's in Windows. I don't know I think that's also in Linux, maybe in Mac OS. So, but before we get started, or go further, I want to ask if someone has any questions so far, how far you are, anything else. Okay, I'm now asking about the difference between CMD and Git Bash. So right now what you're seeing is Git Bash. You can use Git Bash because it's colorful, and you can use some Linux commands in Git Bash. For example, if you want to list the files, you can do an ls. Okay, let's do an ls, and it's going to tell you. But dir will also work. So in command line only this will work, but this is a Linux command, or specifically a bash command. It won't work in command line. I think that's the major difference, for at least for beginners. And it's just easier for a person who is using Linux to use Git Bash on Windows, because then they don't have to think about or remember other Windows commands. All right, so let's go straight into the meat of it. So we did a rename. We asked Git, hey, tell us our status, and Git is going to say that the file that it was tracking has been deleted, but now it says that there is a new file which is not tracked. This is interesting because, come to think of it, renaming is kind of like copying the contents of the original file into a file with a new name and deleting the original file. And this is what is happening here. So Git is intelligent enough to keep track of that original file and not be confused by a Git rename. And so what we'll do is we'll just do Git add and a dot, and it's going to add both of these changes. Otherwise, if you want to do it manually, you will have to git add the name of this file and the name of this file. And then both of these will go into staging, and then we'll be able to commit them. So here I missed out the other command here, but you'll have to git add both of these files. They'll be ready for staging. We'll do a git commit. We'll say first story was renamed, fixes hashtag #1. We'll do a git push. Now, one feature of GitHub is that you can reference the issue number within the git commit. And what this allows you to do is, let's say you fix an issue, then you can directly close that issue from within your commit message, and you don't have to open GitHub. And within GitHub, when you go to the issues tab and you open that issue, it's going to look a bit something like this. It's going to say author close this in the following commit. All right, hopefully everyone is still with me. All right, cool. So quick recap. Commands we have to run once. Clone command we got to run multiple times. Add, commit, and push. Optional commands, but very helpful because we don't want to do some work which is not 100% and show it to all of the people. So it's better to do a git diff on locally and be sure that, okay, whatever changes I have made, if someone else sees them, it's going to be okay. All right, so let's go over the Medium Git workflow where I'm going to do a live demo because it's just going to be terribly slow using slides. I'm going to explain what is Git Branch, what is Git Checkout, and maybe we can even do a pull request. Okay, and for this part, you don't have to follow me. You can follow me, but I want to explain what are Git branches. So Git branches are essentially a copy of the main branch. So I have the main branch here, and let's just say, well, whoops, first story. And I committed my first story. Let's say I fixed the first story. Okay, so now we have a branch. It's the master branch or the main branch on GitHub. And we have a few commits inside of it. And visually, this is how it looks like. So now let's say some author is going to keep working on the first story, but I want to change the first story completely. I also want to, someone else wants to work on the story. What they can do is they can create a Git branch. And what it's going to do is it's going to copy master, and it's going to allow me to have a separate copy of master and be able to work on it while someone else is working in master. So I can do whatever I want in story twist. And in the end, if I don't like it, I can just delete story twist. But it's good for, really good for experimentation if you have a quick idea and if you want separation. For example, let's say if you are working on a feature in a coding project, it's an experimental feature, and you don't want to mess around with what is in master because that has to work for 100% of the time. And so you create a new branch. You're going to start committing in it. First, let's move to the new branch. So right now we move to this branch and we can do a git commit. And now let's say someone else was working in master. And so as you can see, master is on its own branch, story twist is on its own branch, and you can work in story twist, but it's separate from master. So Git branches just allow you to separate your work if it's experimental mostly. That's what we use Git branches for. But what I have seen is that it's a bit slow to use Git branches. Most of the time, while I was a student, I just used to work on the main branch because I was the only one. But if you are working in a group, you can have multiple branches and work separately. And then let's say I'm happy with the work I have done in my branch and I want to put it into master. What I will do is I will go into master using the command git checkout. We go here. We are going to say git merge story twist. And so right now, what we just did is we merged story twist into master, and this created a new merge commit. And now whatever work we have done is also present in master.
Faisal, I want to ask one question. Let's say if someone wants to work in a synchronized environment, let's say if someone is working on the same function,
Mm-hmm.
then how we can do the Git operation on this?
Okay, so they are working in the same function, right?
Yeah. Let's say if the variable name that I want to choose is the same, it could be different, but
Mm-hmm.
like if one of my friend chose another variable name, I chose the separate variable name, so it would be really difficult to synchronize it. No.
Yeah, it will be difficult. So I'll give you a live example. How about I go into, I wanted to give you a visual example first of what story branches are, because if you can understand it visually, it will make more sense when you're doing it in the command line, because in the command line it's a bit difficult to visualize. So if you guys understood the visualization, just let me know and I'll go ahead and um, I'll do a live demo of let's say two people are working on the same function. So if everyone's ready, just post in the chat you're ready and we can go ahead. Okay, let's go. All right, so GDSC kindly made their own repository. What I'm going to do is I'm going to clone it really fast. Okay, so this is my local branch that I'm working on. And now I want to create a branch. I can create a branch locally, or I can also create a branch from here. Whoops. I think GitHub removed that. I haven't really looked at it, but let's go through with the command. Let's name it twist or face. Now I'm going to git checkout Faisal. And the benefit of using Git Bash, is that it will tell you in which branch you are right now. And if you're not in a Git repository, it's just going to be empty. And I hope it's visible for you. I'm just going to increase the font. Okay. All right. I hope Visual Studio Code opens up. All right, let's say I want to name it back to Jinx. And I want to say Jinx was the better name. Let's save it. Go do a git status. I'm going to do git add dot because I know there's only a single file. And I'm on this branch. And when you have a local branch, you need to push it as well, along with the, so let's do a git commit. So let's say I'm a bit angry. I want the original name back. Right now I'm going to push. Okay, so permission is denied. And why permission is denied? Because it's this repository is under someone else's name. So if I want to make any changes, either I can go and ask them and tell them that please add me into this repository. What I can do is just I can do a fork. And now I have my own copy of the repository. And if I make the same changes as I just did right here, I'll be able to contribute back to them. But let's see how I can make changes from here. Let's say I want to edit the README. And this is the problem with live demos. It never goes according to your plan. Okay, so the good news here is that we can easily create a branch. And I can say that improvement. And I can give the committed title. Okay, and propose changes. I'm going to press this. And it will take directly to the pull request because we are doing this on GitHub itself. However, if you were doing this on your own and you cloned your own fork, not GDSC, unless you are a contributor with GDSC, if you could have your own fork, this command is not going to give you this error. It says it's a permission error. I don't have access to it. That's because I'm Noble Ascent and this is under GDSC ELTE. When I make my own fork, my own copy of this, I can just clone it and do the same here. When I do a git push, it's going to automatically create a branch for me. and I can go ahead into branches, and I'm going to see my own branch. From here, I can press on new pull request, and I will come to this same screen. So if you can use GitHub itself, you can do it from here as well. And so a pull request just means that here I'm going to tell GDSC ELTE, hey, you know what? I want to contribute to your project. I want to improve something. I want to change something, and this is what I think. And it's a request, so it will go here, and GDSC ELTE has the full authority to accept or reject this this pull request. So I want to tell people why this repository was created. As soon as they land on it, they will know that, okay, this repo was created because of this event. And I'll create a pull request. Oh boy, oh boy. I just made a bit of a mistake. Should have been doing this over here, not in my own repository. All right, let's just forget what just happened. But it's the same process. You open a pull request. So I forgot that I was on my own repository and not here. When you're doing a pull request, you need to be in the original repository. And we are going to create a pull request, and it's going to say that I want to merge one commit into the main branch of GDSC ELTE from my own account, whose branch is this one. And so what's going to happen is that if Mehdi was working on the same function as someone else and someone made a pull request, if there was no problem, they would have a green mark right here. But let's say there is a bit of a problem. Now I'm going to need a bit of help from Amna or whoever is in charge of this one. I want you to edit something. I want you to change the first line.
What? I can't see
That-
the changed.
Just change the first line. You can write there whatever you want.
Is that the? But I don't see a pull. Okay, I have a pull request now. I see it.
You can do it
Should
from.
I merge the pull request or what?
No. Don't merge. Don't do anything. Just go into your dashboard. Go into your README, or from outside here, you can press this edit button and add something. Just a dot, a space, something, and make a commit, but directly to the main branch in GDSC ELTE stories.
And my stories one, right?
Yeah, in your stories, because I want to create a conflict here. I want to say that I'm not changed the same line that I have changed
one.
in the repo. Yeah.
I did for the README.
Yeah, for the repo. Okay. So now we have a conflict. So what does a conflict mean? Conflict means that someone else made a change in the same file and more specifically on the same line. Oopsie. So where's the Git line? Okay, wait a second. Yeah, okay. So now you can see Amna made this change. She added a smiley face. While I was working on the same file, I made a change. I deleted the whole line. I added 3 new lines. And this is what Git is telling me. It's telling that, you know, this branch has conflict that must be resolved. So let's go ahead and try to resolve the conflict. So we can do conflict resolution from GitHub itself, but we can also do it from the command line. I think for a beginner, it's just better to do it from GitHub itself, because you can do it. So what we have is this line. And the first line tells us the change that I made. And it tells me that this change comes from the following branch, which is noblesse and improvement. And the change was these. And the change that is latest into the main is this change. So now it's up to me to see, okay, which change I want to include. And this can be the same for a function. It can be, let's say, var x is equal to 2. And out here, it would have been var x is equal to 3. So now I have the decision here to resolve the conflict by saying that, you know what, my change is better. So I'm just gonna go with that one.
And actually, who is going to commit this change? Like, who has the decision to make, to resolve this issue?
But any contributor, anyone else, whoever has access to the repository can solve this. So right now we have a tick then, and we press commit because we have to resolve it. So, and now it says that this branch has no conflicts with the base branch. And I can do it. I can fix the conflict. Amna can also fix the conflict, but I don't have the authority to approve the pull request. Whereas if Amna opens this screen, she will have the button here to approve the pull request. So maybe if I go into my own pull requests, I can see that, well, you know, I can merge the pull request. So this is kind of what Amna will see on her screen. And I can press merge pull request, and it's going to create a new commit, which is going to mention this pull request. We confirm the merge. The change has been merged. And if we go back into the code, we'll see that, well, readme contains var x is equal to 3. And it's going to be the same if Amna does it from her side. Into stories, I think, Amna, if you can go ahead and merge the pull request, we'll be able to see. Yeah, so it's merged and closed. And so we have the updated here. And what we can see is that this is the distributed nature of Git, is that I have the same repository. Amna also has the repository, and I can work on my repository and make a pull request into GDSC ELTE and tell them that, oh, you know what, I have a pull request for you. It has an improvement, and if there is a conflict, I can make a commit and update the pull request again. And I know this was a lot of information, so I'm waiting for your questions if you have any. And then I just have one last thing. I'll show you visually through the graph kind of how merging and conflict resolution works, if we have the time for that, because I think I don't want to go into the next quick labs.
It's not today. That's fine. Like it's just an introduction to Git and GitHub, so that is okay.
Yeah. Okay. I think we went into the medium level.
Mhm.
We went into the medium level. We did a Git branch. We did a checkout. We did the pull request. Mostly, what will happen is that you will be added as contributors to the repository. So you wouldn't have to do a git fork. For example, let's say okay, let's say tools or software projects are software technology. In these, you will be grouped together, and you will have a single repository. You will use branches. You will use pull request. You will do merging, but you wouldn't have to do a fork. Because you will be added as contributors to that repository. I had to do the fork because I wasn't added. I just want to clear that up, why I did the fork.
Well, that's okay, I guess. Does anybody have any questions? I actually had a question about merging. So, like, if you merge like, is it possible that the main branch merges into yours? Like, it works the other way around?
Yeah, let me show you. So you want to merge what is in master into your own branch, right?
Right.
It's pretty easy. Let's, oh no, I don't want to clear this. Let's go into master and let's make a few commits. Git commit one. Okay. And you want to have master essentially copied into your own branch. What you can do is you can go git checkout. You can go to your own branch and you can say git merge master. And that's it. Now you can do a git commit. Hey, commit on story twist. And right now, so what you just did was merge master into story twist.
Thank you.
So if you want to, let's say, git merge master. If you want to merge master into a story twist, you need to check out story twist first and then issue this command. If you want to issue some branch into master, you need to check out master and then the name of the branch.
Okay. Thank you.
So it works both ways.
Well, I think we're a bit past the ending time, so we're done with the presentation as well. Thank you so much for the session. Yes. In general, it was a lot of knowledge and good one, especially for those of us who are going to start internships and who had no idea about GitHub whatsoever. So thank you so much.
Yeah, Mehdi says it was a big data to digest. So I want to conclude by just saying that if you just use, let's say, where's the cat? Where's the cat? Come on. Okay, so here's the cat. So if you just stick to these commands, and if you're working on your own, I think you don't need much more commands. And But when you start working with other people, then that's where you need the medium Git workflow. You need branches, you need to check out, you need to pull requests. If you're working on your own and you just want to version control your project, you can just use these commands, and you can even stay in the single branch. So I think what my final thoughts are that I want you to start using Git, and just in the beginning, just use these simple commands. Take a project, use these simple commands, and get familiar, get into the habit of using Git. And once the requirements increase, then you can move on to the medium Git workflow. So for me, if every one of you starts using these commands and it integrates them into your workflow, I think my purpose is done. Yeah, I use Git for personal projects because the main thing is if I'm doing a project, I have many ideas, right? And I want to work on those ideas probably at the same time, you could say. Or even, I just want version control. Basically, I want to know that, okay, this is a change I made 10 days ago, why I made this change, and I want a history of it. Because it just, let's say I had a nice function, and I deleted that function, and I said, I'm going to code a new function for that later on. But later on, I didn't have the time for that. So what I just did, I went back into the Git history, went to that commit in which I deleted it. I would just copy that function and put it back again.
All right. Are there any more questions? Because we should wrap up the session soon. Well, if there are no questions, thank you so much, Faisal, for this. And I think we can, if people demand a second session, I really hope you'll be free, because I think we will bother you for this stuff. And soon we will have a second session about quick labs. We will post it on our social media and our event chapter. Thank you so much, everyone, for joining in, and thank you so much for this, Vessel.
All right. Thanks, everyone. It was a pleasure.
All right.
Thank you.
Okay. Good night, everyone. Have a good weekend.
Thank you. Have a good weekend, everyone. Take care.
Bye.
Bye-bye.